Armor plates come in a variety of cuts, or dimensional differences in their coverage. The dimensions of these cuts are almost entirely arbitrary, and depend on what brand you are purchasing from. However, they fall into a few general categories: SAPI, shooter, swimmer, and full. SAPI, or small arms protective insert, cut plates comply with a known military standard. The plates are cropped at the upper corners, and have a slight rounding to the bottom corners. A medium SAPI plate is 9.5 by 12.5 inches. Shooter and swimmer cut are often used interchangeably, both referring to a commercial size plate with an increased angle of cropping on the upper corners, and may also refer to a very small crop at the lower corners, rather than rounding. Some companies reserve the term swimmer cut for their steepest cropping angle, and shooter cut for a commercial size plate with SAPI angle shoulder cuts. The intent of steeper cuts is to provide a greater range of motion at the shoulders, and increase the ease of shouldering a rifle, by removing material that blocks the shoulder joint. Ultimately, the coverage of these cuts are inconsequential so long as the plates fit your carrier, and you are aware that your shoulder junctions may be slightly more vulnerable. Full cut refers to a plate with only a slight amount of cropping at all corners, intended to cover the largest area possible, for use either in the rear plate bag, or in a backpack of some sort. These are generally inadvisable as they are massively uncomfortable, and off-body armor carry is a bad idea. Some plates are multi-curve, or curved on the vertical axis, in addition to the horizontal axis of single curve plates, which allows the plate to better conform to the curvature of your chest. Many people find these plates far more comfortable than single curved plates, due to the more natural shape. People with breasts may also find these plates to be less constricting than single curve plates. However, they are typically a touch more expensive than single curve plates. I would suggest multi-curve plates, if you can afford them. The National Institute of Justice, or NIJ, tests and maintains standards in the US for ballistic armor. Ballistic armor is rated for a level of ballistic resistance. These tests are based on the ability to both stop bullet penetration and prevent backface deformation. Backface deformation is when the force of a bullet deforms the armor and pushes the armor into the body, potentially causing internal damage. Excessively large backface deformation, and any level of penetration, are undesirable in ballistic armor, as they pose risk of injury or death to the user. The common ratings you will see within the NIJ 0101.06 standard are level 3A, 3 and 4. Ratings lower than 3A are not worth your money. Armor that is not NIJ certified generally should not be trusted. Compliance with known standards is what ensures consistency and safety. Level 3 plus armor is a commercial solution intended to fill the gap between level 3 and 4, but more on that later. Level 3A armor can be softer hard armor that stops pistol cartridges up to 357 SIG flat nose, and 44 Magnum soft jacketed hollow point. Level 3A armor is highly likely to stop 9mm and 45 ACP rounds, as they are lesser threat than what is certified by the NIJ. 3A armor is not rated to stop rifle threats. Level 3 armor is hard armor that can stop rifle cartridges up to 7.62 by 51 full metal jacket. Level 3 armor does not fare well against common 5.56 armor-piercing cartridges, such as M855. Some level 3 armor may stop 5.56 M193 full metal jacket ammunition, but is not certified by the NIJ to do so. Level 3 plus or special threat armor is not a proper NIJ rating, for now. The NIJ is working on a new set of ratings called 0101.07, to better specify modern levels of ballistic protection. More on that later. Many current special threat plates are level 3 rated, with additional protection for 5.56 armor-piercing cartridges, as well as multiple hits of 5.56 or 7.62 by 39 cartridges. Special threat plates vary widely in quality and resistance between brands, so ensure you research exactly what cartridges your special threat plates are capable of resisting. Most but not all special threat plates are resistant to 5.56 M855, and only some are resistant to M855A1. For the time being, special threat armor that is NIJ level 3 rated from a reputable brand such as RMA is an optimal choice for a civilian looking to get over ballistic armor. It is lighter and thinner than level 4, but still provides adequate protection against the cartridges they may typically face. Level 4 armor is hard armor that can stop rifle cartridges up to 30 caliber armor piercing. Level 4 armor is typically heavy and thick, or prohibitively expensive for civilians. The NIJ 0101.07 standards, at time of writing, have not been implemented yet. They are intended to replace the numeric standards that the NIJ currently certifies. The handgun, or HG threat levels are HG1, formerly Level 2, which stops standard velocity 124 grain 9mm full metal jacket rounds, and 357 Magnum jacketed soft point rounds. And HG2, formerly Level 3A, which stops 124 grain 9mm as before, as well as 240 grain 44 Magnum jacketed hollow point. The rifle, or RF standards are RF1, which stops M80 standard 7.62 by 51 full metal jacket, a 7.62 by 39 circuit rounds, and M193 standard 5.56 rounds. RF2, which stops the same as RF1, in addition to M855 standard armor penetrating 5.56 rounds, and RF3, formerly Level 4, which stops M2 standard 30-06 armor piercing cartridges. The RF2 standard is the optimal choice for most civilians looking to purchase body armor, as it represents the most reasonable threats they face, without excessive weight in bulk. There are two common types of armor, soft armor and hard armor. Soft armor typically is made of fabric woven from aramid or Dyneema fibers. The common brand name for aramid is Kevlar. Soft armor can provide up to NIJ Level 3A protection. Aramid is susceptible to degradation from sun exposure, humidity, water, and excessive heat, and will delaminate over time. Dyneema experiences many of the same issues, but is lighter, more resistant to UV, more durable, and more expensive than aramid. Soft armor is suitable for when concealable armor is required, and rifle threats are not a concern. Hard armor is typically made from one or more of the following materials: steel, ultra-high molecular weight polyethylene, UHMWPE, or ceramic. Hard armor is heavier than soft armor, and is not flexible. It is harder to conceal. Hard armor can provide up to NIJ Level 4 protection. Certain specially made hard armor plates may be used in conjunction with soft armor for increased protection. Hard armor may be made from multiple layers of different armor materials. Steel is excessively heavy when compared to other armor types. Even with anti-spall coatings or polyethylene on top, when a bullet impacts steel armor, the metal will spray outwards along the face of the plate, potentially into your arteries. This metal splatter can also hurt people around you, even if it does not hurt you. Never purchase steel armor. UHMWPE armor is made from an extremely dense form of plastic, and can provide up to Level 4 protection, when properly layered with other materials. Level 4 polyethylene plates are often excessively thick, and you should only consider up to Level 3+ polyethylene plates. Polyethylene is lighter than both steel and ceramic. It is vulnerable to delamination and deformation when exposed to sustained heat or sunlight, due to both the properties of the material and the adhesive used for layering, but not to other environmental factors like water. Polyethylene can be buoyant. Polyethylene alone cannot resist armor-penetrating ammunition, but can be paired with a ceramic layer to prevent this. Ceramic armor is made from layers of ceramic, and can provide up to Level 4 protection and beyond. Ceramic armor does not spray like steel, but can throw low-velocity ceramic shards out when impacted, which are not moving fast enough to harm the wearer. A simple layer of UHMWPE can help prevent this. Ceramic is unaffected by water, humidity, and UV, but it can delaminate when exposed to prolonged excessive heat. Ceramic is lighter than steel, and heavier than UHMWPE, but it is the thinnest material by far. In order to be multi-hit capable, it must be adhered to an additional layer of material.